ఓకే.
Belated happy Diwali, sir.
థ్యాంక్ యూ. ఇంకా మన క్లాస్ డిస్టర్బెన్స్ ఏం లేదుగా? ఇంకా అన్ని
No,
క్లాసులు
sir.
అయితే కెమిస్ట్రీ క్లాస్ ఆల్సో ఓవర్. అంతేనా?
అయిపోయింది సార్.
ఓకే, రైట్ రైట్. గుడ్ మార్నింగ్ రిషికేష్. ఇక మనము వేర్ వి స్టాప్డ్ ప్రీవియస్లీ.
బోర్స్ మోడల్ స్టార్ట్ చేసి ఆపేశారు సార్.
ఓహో, బోర్స్ మోడల్ స్టార్ట్ చేసాం అంటే బేస్డ్ ఆన్ క్వాంటమ్ థియరీ. ఓకే, కమ్ టు హియర్ బోర్స్ మోడల్.
Sir, you told you will derive that formula, sir.
Which formula?
That second application, sir, that impact parameter.
180 degree.
180 degrees. Which one?
Impact parameter one, sir. From those four formulas, we need to derive that final expression.
Which one? Okay. Tomorrow we will derive what happened. What is that?
Okay, sir.
Once you remind tomorrow.
Okay, sir.
Which one? That also you try to say that equation. Which equation is to be derived?
Okay, sir.
Which one you are saying that cot theta by 2?
Yeah, that one, sir.
Okay. No problem. Tomorrow we will derive.
Okay, sir.
Right. Come to here, Bohr's theory. In this theory, Nana, first of all, actually that wave theory, what they took means Rutherford took, failed there to explain the existence of the orbits and the electron inside the atom. That's why he took based on quantum theory. Okay. Now he is trying to say a few concepts related to it. According to quantum theory, energy is quantized. Okay. And it is discrete. Energy is discrete. And quantized. Okay, any energy will be the multiple of h nu kada nana. 1 h nu, 2 h nu, 3 h nu. That's why it is energy is quantized. So you understood that one? Energy is quantized means.
Yes, sir.
Yeah, and here in between h nu and 2 h nu, no energy will be there. Suppose this is 2 electron volts, then it is 4 electron volts. In between 2 and 4, 2.1, 2.2, 3, 3.9, such type of energies are not available. That's why it is discrete and quantized. So based on this quantum theory, what he said, inside the atom, suppose this is the atom what we are taking, and there will be nucleus inside it. This is the size of nucleus what we are taking. And here, since the energy is quantized, you can assume that the electrons, what his guru said, revolve around the nucleus outside only, not inside the nucleus. And he proposed those electrons revolve only in circular orbits like this. These are the circular orbits what he proposed. Since the energy is quantized, okay, suppose h nu is the energy of first orbit, then up to 2h nu, no orbit in between those two, and there will be no electron in between those two. So here it will be the orbit of means the energy state of 2h nu. And in the same way, he proposed the next one like that. He proposed discrete energy levels, which are called as, those energy levels are called as orbits. Now you understood, Nana? These white circles are orbits. Okay. Red is nucleus. Blue is the atom. Okay, that's it. So first time we are finding out the energy states. Those energy states are called as orbits. Okay, orbits are nothing but not the existing paths. They are, orbits are nothing but are the energy states of electrons. Okay. So as you learnt in your chemistry, the electron will not exist in between two orbits. Why? Because there is no energy for the electron. So there will be no orbit. Energy level is nothing but the orbit. Okay. That's why electrons revolve only in particular orbits. What? He changed the story. Okay. And here, since the energy is quantized and discrete, when an electron is revolving in a particular orbit, okay, in a particular orbit, the energy is neither lost or nor gained. Lost nor gained in a particular. That means in a particular orbit energy level, when it is revolving, it won't lose any energy. It won't lose any energy means the second drawback what we found in Rutherford, that is the electron is not losing the energy. Okay, how is it possible? He proposed circular orbits. So at every point in a circular orbit, the centripetal force is balanced by centrifugal force. Okay, that implies F net is equals to 0, no force here. That's why there is no loss of energy. According to Newton's law, if the net force equals to 0, the body can move with constant velocity without losing any energy. Now there is no chance of falling that electron inside the nucleus. That's why happily electrons revolve around the nucleus years together, decades together, centuries together. That's why the atom won't destroy. That's why first he said, 1 minute, Nana, HK sir is calling. Okay, I will put in mute for a while. Okay, sorry for the disturbance, Nana. And here, this is F net equals to 0. Okay. Now, any doubts in the points here, what I wrote?
No, sir.
No, sir.
No.
No doubt.
Yeah, and one by one here, how he clarified the drawbacks what we found in the Rutherford's theory. Okay. And here, when an electron means here we don't know why he focused only on the single electron atoms, means hydrogen atom. He studied the hydrogen atom, Nana. Hydrogen atom means how many electrons will be there in the hydrogen?
One, sir.
One.
That's why he said, he explained the theory, okay, for whom the atoms
Single-celled electron.
single
Single electron atoms.
yeah, for the atoms having single electron. That's correct. One electron. I think in the basic story only we found one drawback here. All the atoms, they won't possess one electron. Then later, of course, many scientists asked, if I take a helium atom, what to do? He said, like us.
Plus one condition.
Lithium, if I take, just remove 2 electrons. This is not fair, na?
Yes, sir.
3 electrons means remove 2 electrons. 20 electrons are there means remove 19 electrons. What is this nonsense? Okay, means he restricted his theory to only 1 electron, Nana. That was a big flaw in his theory. Okay, of course, while discussing the drawbacks there, we write this point. What is the flaw here? First, we try to appreciate the development in the existence of electrons. Actually, we have to give some appreciation to him. Okay, so according to the theory, quantum theory, what he explained, of course, he explained many concepts here, Nana. Okay, what are those concepts he explained? Number one by one, we will take. Okay, here, the first postulate, what he said. First postulate of Bohr's theory. What is that first postulate, Nana? Anyone remember?
Electrons revolve in circular orbits called orbitals.
Not orbital, orbit. And
They have fixed energy levels.
okay. And
Each orbit has fixed energy levels.
yeah, that's what I said here. Each orbit has fixed energy.
Yes.
Okay, discrete. Here only, discrete and quantized. Okay, right. Each orbit has fixed energy. And it is a characteristic. Is a characteristic energy of an, it is a characteristic energy. That's it. Means what is the meaning of this one, Nana?
Distinct energies, sir.
Not like, suppose.
Sir, means
Tell, Nana. Suppose. Neha.
సార్ ఇప్పుడు ఫస్ట్ షెల్ ఉంటే దానికి ఎంత ఎనర్జీ ఉంటుందో సేమ్ ఎనర్జీ వేరే షెల్ దేనికి ఉండదు అలా.
షెల్ అనుకో, ఆర్బిట్స్ అను. షెల్ అంటే మళ్ళీ 3 డైమెన్షన్లోకి వెళ్ళినట్టు.
అదే సార్ ఆర్బిట్.
ఆర్బిట్ అంటే 2 డైమెన్షనల్. 13.6 electron volts is the energy of first orbit of hydrogen atom. ఇక ఈ ఎనర్జీ ఇన్ ఎనీ atom for any orbit you can't find. అంటే the electron energy of an electron is, suppose you say minus 3.4 electron volts అన్నావనుకో, then directly I say, oh, minus 3.4 electron volts means it is an electron revolving in a hydrogen atom second orbit. అంటే I can find out the element as well as the orbit by the energy. అది ఆయన చెప్పేది. క్యారెక్టరిస్టిక్ ఎనర్జీ అంటే అది మీనింగ్. అంటే ఆ ఎనర్జీ ఇంకా ఏ ఆటంలో ఏ ఆర్బిట్కి ఉండదు అని చెప్తున్నాడు. నవ్ యూ అండర్స్టూడ్ దిస్ పాయింట్ నాన్న?
Yes, sir.
రైట్. ఇది కూడా ఒక పెద్ద ఫ్లా. దీంట్లో ఉన్న మిస్టేక్ మళ్ళీ లేటర్ అనదర్ సైంటిస్ట్ రెక్టిఫైడ్ యాక్చువల్లీ. సరే చూద్దాం. ఇట్ ఈస్ ఎ క్యారెక్టరిస్టిక్ ఎనర్జీ. ఓకే. And here while revolving, he proposes circular orbits or elliptical orbits?
Circular
Circle.
orbit.
Orbits are in the circular shape.
Sir, angular momentum is multiple of h by 2 pi.
That is second postulate.
Okay.
Yeah, Rishikesh, that is second postulate.
సార్ ఇక్కడ సర్క్యులర్ ఆర్బిట్స్ అన్నారు, కానీ మనం ఇప్పుడు ప్రస్తుతం వాడే దాంట్లో డంబెల్ షేప్ ఆర్బిట్స్ అలా ఉంటాయి కదా సార్, ఓన్లీ సర్క్యులర్ ఎస్ ఆర్బిట్ ఉంటుంది కదా.
అదే కదా. తర్వాత ఇవన్నీ అంటే బేసిక్ థియరీస్ నాన్న, ఇవన్నీ కూడాను.
అంటే ఇప్పుడు ఇక్కడ ఈ యాక్సిలరేషన్ 0 అనేది ఇక్కడ వచ్చింది, కానీ ఆ డంబెల్ షేప్ దాంట్లో అది 0 అవుతుందా?
దీంట్లో ఏంది, ఎలిప్టికల్ లో కూడా కాదుగా.
మరి అది ఎలా కరెక్ట్ అయింది సార్?
అదే తర్వాత వస్తాయి, మోడిఫికేషన్స్ వస్తాయి.
ఓకే సార్.
ఫస్ట్ సింగిల్ ఆర్బిట్, సింగిల్ ఎలక్ట్రాన్ కి ఆయన ఏ ఆర్బిట్ అయినా ఉండొచ్చు. దట్ సింగిల్ ఎలక్ట్రాన్ కాబట్టి దెర్ ఆర్ నో ఫోర్సెస్ బిట్వీన్ ద ఎలక్ట్రాన్స్. దెర్ ఇస్ ఓన్లీ ఫోర్స్ బిట్వీన్ న్యూక్లియస్ అండ్ ఎలక్ట్రాన్. కాబట్టి ఒకటే ఫోర్స్ ఉంటుంది కాబట్టి సెంట్రిపెటల్ ఫోర్స్ ఇస్ బ్యాలెన్స్డ్ బై సెంట్రిఫ్యూగల్ ఫోర్స్ అని ఒక కాన్సెప్ట్ డెవలప్ చేశాడు ఆయన. ఇప్పుడు మన ప్లానెట్స్ కూడా ఫెయిల్యూర్ అయింది అందుకే కదా, సర్క్యులర్ ఆర్బిట్స్ కాదు ఎలిప్టికల్ అని మాడిఫై చేయడానికి రీజన్ అదే.
ఓకే సార్.
అంటే అది కొద్దిగా డెప్త్కి వెళ్తే మనకు అర్థమవుతుంది ఆ కాన్సెప్ట్. సర్క్యులర్ అసలు ఎందుకు చేంజ్ చేయాల్సి వస్తుంది ఎలిప్టికల్కి అన్నదానికి రీజన్ అదే. ఒక ప్లానెట్ కాదు కదా, నెంబర్ ఆఫ్ ప్లానెట్స్ ఉంటాయి. ద ఫోర్స్ ఆఫ్ అట్రాక్షన్ బిట్వీన్ ద ప్లానెట్స్ ఏమైనట్టు అని ఒక క్వశ్చన్ వస్తుందిగా. అదే ఫర్ ఎగ్జాంపుల్ ఒకటే ప్లానెట్ ఉందనుకో, యూ విల్ ఫైండ్ ఓన్లీ వన్ ఫోర్స్ బిట్వీన్ దెమ్. ఎర్త్ అట్రాక్ట్స్ సన్, సన్ అట్రాక్ట్స్ ఎర్త్. ఇక ఏమి ఉండవు అరౌండ్ శాటిలైట్స్, ఎనీథింగ్, నథింగ్ వీఆర్ టేకింగ్. కానీ అది ప్రాక్టికల్ గా పాసిబుల్ కాదు కాబట్టి లేటర్ టు బ్యాలెన్స్ ఆల్ ద ఫోర్సెస్ దే ప్రపోజ్ ద ఎలిప్టిక్ ఆర్బిట్స్. అలాగే ఇక్కడ సేమ్ ప్రాబ్లం వస్తుంది మనకి. ఓకేనా?
ఓకే సార్.
దాని నుండి ఎస్కేప్ అవటానికి ఒక పెద్ద దాల్లో తీసుకెళ్లి లెగ్ పెట్టాడు. పుట్ ద లెగ్ ఇన్ దాల్ అంటాం మనం. ఈయన పెట్టింది అదే ఇక్కడ. ఓకే. And then here, since he proposed only one electron atom, single electron atoms, in that only one force will be there, that is centripetal force, and it is always balanced by centrifugal force. This is first postulate nana for us. Okay, since the centripetal force is balanced by centrifugal force, okay, between the electron and nucleus, and of course, and also, okay, nucleus, and there are no other forces exist inside the atom. That's why according to his theory we have to accept always while revolving centripetal is equals to centrifugal. So according to his concept, centripetal force means it is a real force. Real force means we have to take which type of force? That one we have to take, Nana?
Force of attraction.
Yeah, force of attraction between electron and nucleus. Electrostatic or some other?
Electrostatics.
So electrostatic force of attraction we are taking. That electrostatic force of attraction is 1
by 4 by epsilon naught q1 q2 by r.
Yes, q1 q2 means q1 electron
Ze.
nucleus Z. Okay, this is centripetal force, and that is balanced by centrifugal force, mv square by r. Means here we are coming to the derivation of velocity and radius. Why? Because rest of the things are constants. So from this, what can we write? 1 by 4 pi epsilon naught into Z e square by r is equals to mv square. Okay, let it be the equation 1. Take it as equation 1. Okay, right. Equation 1 here. This is. And this is the equation what we got from first postulate. Now move to second postulate. Here. Come to the second postulate. This one already you told. The angular momentum is constant and it is integral multiple of h cross. That all of you know. So the angular momentum of the electron is constant in an orbit. And that L is equals to, which is mvr is equals to, no need to take sine theta, nana. Why? Because he proposes circular orbits. So linear momentum and perpendicular distance are always perpendicular to each other. So in r cross p, no need to write r into p into sine theta. Sine 90 becomes 1. So in this case, angular momentum L magnitude is mvr straight away, that is equals to nh by 2 pi. What we write it as nh cross. H cross is h by 2 pi. That value is. Okay, this is the story, Nana. Okay. Yes. Sir, can you show the previous slide once? Who is this Barber? Okay, sure, master. Now moving to here. This is MVR. Oh, okay, Nana. MVR is equals to NH by 2 pi. This is actually second postulate, Nana. Okay. That implies L is always integral multiples of H cross. Okay, where n is not equal to 0, Nana. N is number of orbit. Okay, and that is equals to 1, 2, 3, so on. Any value you can take except 0.
Sir, what is that, sir? That H and one line you
H cross,
H by 2 pi.
H cross is H by 2 pi.
Okay, okay.
Since H cross is equals to H by 2. Okay, na? Right. So this is the story, Nana. And from this we got second equation that implies straight away separately I am writing here mvr is equals to nh by 2 pi. And here from the two equation I am going to eliminate either v or r. Okay, so I am taking it as second equation mvr is equals to nh by 2 pi. And from 1 and 2 I write. Okay, from 1 equation 1, since it is mvr, better I take cross multiplication, Anna. mv square r is equals to 1 by 4 pi epsilon naught ze square. I can write here what can I write here? mv square into r is equals to 1 by 4 pi epsilon naught ze square. Am I right? Any mistake here? mv square into r, correct?
No, sir.
That implies I write it as mvr into v is equals to 1 by 4 pi epsilon naught z e square. Now mvr I am replacing with nh by 2 pi. That is nh by 2 pi into v is equals to 1 by 4 pi epsilon naught into z e square. That implies v is equals to, you are getting here 2 pi 2 times cancel, Nana. If you cancel here, you are getting v is equals to what? Z e square by 2nh epsilon naught. From this we can write, this is the original equation of v, Nana. Okay, velocity. But I think in your chemistry, you know that v is directly proportional to z by n, if I am not wrong. మీకు అది తెలుసు అనుకుంటారా?
What, sir?
In your chemistry, you know that v is directly proportional to z by n.
Yes, sir.
With the increase of number of orbit, velocity will be decreased.
Yes, sir.
And that is different in different atoms by changing the z number. So you know it actually in your chemistry, but that v is equals to how much into z by n, that you know? Actually some constant, na?
Yes, sir.
Do you know that what is that value? Constant is nothing but e square by 2h epsilon naught, na?
సార్ అప్పుడు ఎప్సిలాన్ నాట్ ఇంకా చెప్పలేదు సార్.
ఏం కాదురా, కెమిస్ట్రీలో రా, మీకు తెలుసా ఈ వాల్యూ ఉంటుంది?
లేదు సార్, అంటే
అయితే ఓకే, ఒకసారి క్యాలిక్యులేటర్ తీసుకోండి. E square means 1.6 into 10 to the power of minus 19 whole square by 2 into h is 6.625 into 10 to the power of minus 34 into epsilon naught is 8.85 into 10 to the power of minus 12. గుర్తుంది అనుకుంటాను, I think. This is the denominator and that is the numerator. How much finally you will get? Anyone is solving?
Sir, 0.0218.
0.0218.
ఇది సార్, దాని తర్వాత నెంబర్స్ పవర్
3412 అంటే -46.
-2
అంటే +46 -38. ఎస్ ఎవరు ఏదో పోస్ట్ చేశారు. 10 పవర్ సంథింగ్
+8 సార్.
10 పవర్
8.
ఓకే కరెక్ట్ ఉంది, రైట్. 10 పవర్ 8 సెంటీమీటర్ పర్ సెకండ్. కరెక్టే వచ్చిందా చూడండి. 1 2 కరెక్టే. నేను దేనిలే 2.18 ని ఐఎమ్ చేంజింగ్ టు 2.2. పర్లేదా?
మార్చండి సార్.
ఏం లేదు, రౌండ్ ఆఫ్ చేసాం. 2.18 ఐ రోట్ ఇట్ యాజ్ అప్రాక్సిమేట్లీ 2.2. క్యాలిక్యులేషన్ ఈజీగా ఉంటుంది కదా. ఓకే రైట్. This is which is nothing, this is in centimeter per second, or else you can write it as 2.2 approximately into 10 power 6 into z by n meter per second. Anyone you can remember, that is your wish. ఎలా అనుకుంటే అలా గుర్తుపెట్టుకోండి. Okay, that value will you say in terms of speed of light? C value is 2.98 into 10 to the power of 8. So here 290 by 8 by 137. How much once we check? Means approximately 300 by 137.
2.17.
This value you are getting or not?
Yes.
So this value is in terms of speed of light also they said for our numericals, c by 137 approximately. V is equals. So keep in mind, here it is not actually moving with a high speed, the electron, but I think it is not comparable to the speed of light. So no need to take m is equals to m naught by root of 1 minus v square by c square in the derivations. Ardhamayinda?
Sir,
Ah.
it's into z by n, no, sir, in last.
Yeah. Into z by n is there. Just this
Okay.
constant value I'm telling.
Okay.
Okay, right. So is it clear, Nana?
Clear, sir.
Yes.
So no need to take this value. V square means 137 whole square is very small value. That's why no need to consider. Okay, that's why I'm erasing this one. And here in these derivations, no need to use m is equals to m naught by root of 1 minus v square by c square. So, or even you can use this equation here while solving the numericals. Okay, good. Keep in mind all these equations to solve the numericals.
Sir, here z value is only, we can use 3 or 4, no, sir. 1, 2, 3, 4.
Z value.
Yes, sir.
Z value depending upon atom kada nana.
Yes, sir. Means like only it applicable till beryllium, no, sir. Beryllium plus 3.
Who said?
Means, sir, for higher energy, means like for more atomic number elements, we can use this formula.
He said you can use, but limitation he said now. What the electrons, all the electrons you have to remove except by keeping one electron inside.
Okay, sir.
Means this is applicable only for atoms having single
Single
electron atoms. So if you go to like iron or like carbon or like some oxygen, their number of electrons more. It is not so easy to remove all the electrons by keeping just only one electron inside.
Yes, sir.
That's why all these are actually later what they found, Nana. The restrictions and limitations in the Bose theory.
Okay, sir.
Okay.
Okay.
First we are
సార్ మరి
discussing.
వాటికి ఫార్ములా ఉంటుందా ఇంకోటి?
అంటే కొద్దిగా మాడిఫై చేయాల్సి వస్తుంది అన్న. అవి మాడిఫై చేయాలంటే ఎక్స్రేస్ గురించి తెలియాలి మనకు. ఎక్స్రేస్ గురించి తెలిస్తే మాడిఫికేషన్ వీ కెన్ ఫైండ్ అవుట్. ఎక్స్రేస్ చెప్పిన రోజు మాడిఫికేషన్ డిస్కస్ చేద్దాం.
ఓకే.
అఫ్ కోర్స్ సర్క్యులర్ ఎలిప్టికల్ ఆర్బిట్స్ నాట్ దేర్ విత్ ఇన్ అవర్ సిలబస్. అందుకనే మనం సోమర్ఫీల్డ్ థియరీ, స్టార్క్ ఎఫెక్ట్, జీమన్ ఎఫెక్ట్ వీఆర్ నాట్ గోయింగ్ టు డిస్కస్.
ఓకే.
అవన్నీ డిస్కస్ చేస్తే యాక్చువల్లీ విల్ గెట్ మోర్ క్లారిటీ అబౌట్ దాట్. కానీ unluckily here that part is not there in our syllabus. Okay, so this is velocity, Nana, and this is the formula to be used for our numerical physics numericals. So buttify cheseyali formula. Okay, it is a shortcut. And here conclusion, with the increase of order of orbit, means number of orbit, the speed will be decreased. Speed of electron is decreased. Okay, this is the conclusion what we found. And from the first and second postulate, you can say the formula for radius also, Nana. Okay, just to keep v value here in this equation, you can find out the radius. Okay, so here suppose if I take this from equation 2.
Sir, here for radius constant is 0.53, no, sir?
Yeah. That constant we have to get it now. And is it correct or not? Again, using the calculator, we have to check or not.
Yes, sir.
Yeah. From the equation 2, I am going to substitute m into v z e square by 2n h epsilon naught. Correct, Anana? 2n h epsilon naught. Correct. mvr is equals to nh by 2 pi. So I think here 2 get cancelled. I am getting the radius equation r is equals to, by taking cross multiplication, n square h square epsilon naught divided by pi. And here if you take all the terms to the denominator, pi mz e square. So is it clear on a radius equation?
Clear, sir.
Any
Clear.
mistake I did in the derivation? ఏమైనా తప్పు చేశానా నేను? No, I think correct. Yeah, everything. Correct only.
Correct, sir.
And now you can check what are these. I mean, according to chemistry, you know, in our chemistry, r is directly proportional to n square by z. Yeah, all of you know this. N square
Yes,
by
sir.
z. But constants, ఇక మళ్ళీ calculator పని. 6.625 into 10 to the power minus 34 whole square. Epsilon naught 8.85 into 10 to the power minus 12 divided by pi value 3.14, m value for electron 9.1 into 10 to the power minus 31 into e value 1.6 into 10 to the power minus 19 whole square. Fast ga ఎవరైనా scientific calculator ఉంటే fast గా solve చేస్తే we will get the value. That is 0.53 approximately.
సార్ 5.29 వచ్చింది సార్.
Exactly correct.
10 పవర్స్ అది నేను చేయలేదు.
5.29 అంటే 5.3. 34 అంటే 68 ఒక 12 అంటే 80 న్యూమరేటర్. డినామినేటర్ 31 minus 38 69 కరెక్ట్. 10 power minus 11 వస్తుంది. ఓకే నాన్న.
Okay.
అంటే 0.529 into 10 to the power of minus 10 meters. కాబట్టి 0.529 angstroms. అది 0.53 approximately we wrote. So that value is correct. So ఇప్పుడు అరెస్ట్ చేసేసుకోవచ్చు మనం.
Yes, sir.
Right, good. This is the value what we got here. Right? So this value also you have to remember, Tana. 0.53 angstroms into n square by 6. Okay. For our physics numericals, మనం ఇది కూడా యూస్ చేయాల్సి వస్తుంది when we come to our numericals. This is one formula, equation 5. ఓకే, ఇవన్నీ ఎందుకు బట్టిఫై చేయాలి సార్ అంటే బిట్సాట్ ఎగ్జామ్ కోసం, మీ బిట్స్ కోసం. బిట్సాట్ లో ఫార్ములా ఉంటుంది స్ట్రైట్ అవే ఇన్ ఆప్షన్స్, అది ఐడెంటిఫై చేయగలగాలి. దే వోంట్ ఆస్క్ రేడియస్ ఈస్ డైరెక్ట్లీ ప్రపోర్షనల్ టు వాట్, n స్క్వేర్ బై z అని పెట్టాను, వాడి మొత్తం ఈక్వేషన్ అడుగుతాడు. అప్పుడు ఇది మొత్తం బట్టిఫై చేయాలి, రేడియస్ ఈక్వేషన్, వెలాసిటీ ఈక్వేషన్. ఓకే, గుడ్. అండ్ దెన్ హియర్ the basic equation is into 5, right? Then after coming to these concepts, here mvr is equals to nh by 2 pi. From this, suppose the de Broglie wavelength, if they ask, Nana?
Sir, mc square is equal to hc
de
by
Broglie wavelength, h by lambda, na de Broglie wavelength, orbiting electron. De Broglie's concept, Nana?
mc square equal to hc by lambda.
Lambda. That one already de Broglie's concept we discussed in the chapter dual nature, na. Lambda is equal to h by p. There we got.
Yes, sir. Yes,
Even
sir.
in
We got
chemistry,
that.
yeah, they are same thing.
Same thing, no, sir. Yes.
Lambda of orbiting electron is equals to h by p. P means mv. And no need to use here. Already I said no need to use m is equal to m naught by root of 1 minus v square by c square. So happily you can replace mv as h by lambda. mv of orbiting electron is equals to h by lambda. Replace there in equation 2. That implies from the equation 2. Equation 2. We write what we write here, mv is h by lambda into r is equals to nh by 2 pi. So h cancel. That implies de Broglie wavelength is equals to, here we are getting 2 pi r divided by n. That implies lambda is equals to 2 pi r is nothing but perimeter, Nana.
Yeah. So this is only out of phase, in phase, no sir, the electron.
Which one?
This 2 pi r by n means we say out of phase, the electron is in the phase, out of the phase.
No need to say why. What is the need of out of phase and in the phase?
Means last year in chemistry, sir told, sir, means if suppose the electron is in the phase, then it
In the
satisfies
phase
the
means to whom?
means its perimeter is integral multiple of the wavelength.
Okay, that is n into lambda. Integral multiple of wavelength.
If the electron is in the phase, means it satisfies this de Broglie's wavelength equation. If it is out of the phase, means it does not satisfy.
Out of phase means with whom, Nana? Out of phase. In phase with whom? Out of phase with whom?
That I don't remember, sir, properly, but it was something in the textbook only, sir. In the phase, the electron is said to be in the phase and said to be out of the phase, like that.
I think that is 2 electron story, maybe.
Okay, sir.
Means
Once
I
I'll
did
check.
not follow exactly what you are saying.
Okay, sir. Once I'll check, sir. Once
Okay.
again, I'll check. Not
Okay.
now, sir. After the class, I'll check, sir.
Okay, then okay. No problem. So this is the de Broglie's wavelength, Nana. Okay. Wavelength of electron. Lambda is equal to perimeter. That implies what he said, perimeter is equals to integral multiples of n lambda of electron. Okay. This one also usually while solving the numericals we use in the problems. Okay. And that one I write here, that implies extra I add some spices to this equation, or I write here lambda equals to 2 pi by n into radius. I write it as 0.53 angstroms into n square by z. That implies I'm going to write this as 2 pi n by z into 0.53 angstroms. So if they ask
Hello, sir.
Hello, sir.
మై గాడ్ నాన్న.
సార్ యూట్యూబ్ లో ఉంటాయి చూసుకుంటాం సార్.
Okay, okay, okay. Because of power loss, I forgot to connecting it to the Wi-Fi hotspot. See, bad luck. Okay, right. Anyway, we completed up to second postulate, Nana. Okay. Will
Okay.
we stop it now?
Sir, one
Okay,
doubt, sir.
Sorry for the yes, yes, yes.
Sir, means according to Maxwell, sir, every accelerating particle will behave like electromagnetic wave, no, sir?
Emits the electromagnetic wave.
It emits then, sir, according Bohr explained line spectrum, no, sir, from his theory.
Nana, again you are doing a mistake here. That is electromagnetic wave theory means there by considering that as the wave, the energy emitted by the electron is considered as wave.
Okay, okay.
But
Here we are
he
using
took the
quantum.
quantum theory, na.
Okay, 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 sir. Okay, okay, sir.
Understood?
Yes, sir. Okay,
Right,
sir.
right. Shall I stop the class now, Nana?
Sir, till 11. Okay,
Okay.
sir. Okay, sir.
Till 11:30 only, no?
ఒక
Okay.
10 నిమిషాలు
10:45
తీసేసుకోండి సార్.
11:30. Am I right? ఇక్కడ ప్రాబ్లం ఏంటంటే నా మొబైల్లో కూడా పవర్ లేదు. అది
Okay.
ఛార్జింగ్ పెట్టడం మర్చిపోయా.
ఓకే సార్.
Okay, sir.
పవర్ లే, అసలు ఇంట్లో పవర్ పోయింది. రైట్ నా?
Okay, sir. Bye, sir.
మళ్ళీ మధ్యలో డిస్కనెక్ట్ అయిపోతుందని నా భయం, అంత మించి ఏంటి.
ఓకే సార్.
ఓకే నాన్న. మీరు అది పేజెస్ తీసుకుంటారుగా ఫ్రమ్ యూట్యూబ్?
Yes, sir.
తీసుకున్నాం సార్.
ఓకే రైట్ నాన్న. బాయ్.
Bye, sir.